So here we'll check out part A of number 4 from the 2014 AB and the BC exam. It's a non-calculator question here, and the situation that's described is that train A is going to run back and forth on a track that goes east-west. The velocity of train A at different times is measured and given to us in this table. So we have the velocity at the 2-minute mark, the 5-minute mark, the 8-minute, and the 12-minute mark. And what we want to do in part A here, I think I'm covering up part of the problem statement. Let's make sure that wasn't important. So it just says selected values for. I think we can do without that. Let me just double check my hard copy of this and make sure we don't need it. Yeah, we are okay. The end of the sentence just says selected values for v sub a of t are listed in the table above, and we already kind of realized that. In part A here it says find the average acceleration of train A over the time interval from 2 to 8. Now, average acceleration, that's probably not something you've done a lot of, but what you have done a lot of is you've probably found average rates of change quite a bit, and the average rate of change of a function generically is just going to be a slope calculation. So the average rate of change of a function on the interval from A to B is going to be found by taking the first y value minus the second y value over the first x value minus the second x value. Now, what's the rate of change of velocity? Well, the rate of change of velocity is acceleration. So another way that they could have asked us part A here is to find the average rate of change of velocity over the time interval from 2 to 8. So really all we have to do is we have to do a slope calculation with ordered pairs from out of this table. So the tricky part about part A here is realizing what exactly you need to be doing. So our average acceleration is going to be v of 8 minus v of 2 over 8 minus 2. And if you take v of 8 from out of the table, that's negative 120. And then minus v of 2 from out of the table, so that's positive 100. And then 8 minus 2 is 6. So we're looking at, let's see, negative 120 minus 100 is going to be negative 220 over 6. This would be measured in meters per minute is what we measure velocity in. So this is meters per minute, or meters per minute squared. So kind of an obscure set of units for acceleration, but that's okay. This fraction will reduce. If we divide top and bottom of this by 2, I think what we end up with is we end up with negative 110 over 3, and I don't believe you can reduce that any further. And I am going to toss the units on here. It's going to be meters per minute squared. I don't think it really asks for those, but that doesn't really hurt to list them. So there is your average acceleration for this train over the time frame from 2 to 8.